Hello, students. Here we are again with Fatima Convent High School E-Physics class, Chapter 8 Motion of Class 9th. Let us move to the next topic of this chapter, that is graphical representation of motion. Now we studied the various quantities related to motion, that is distance, displacement, speed, velocity, and acceleration. Now let us understand the relation between all these physical quantities that we studied and how graph can help us to understand it in a better way. The graphical representation of motion. Graph provides a convenient method to present basic information about a variety of events. For example, in the telecast of one-day cricket match, vertical bar graph shows the run rate of a team in each over. As you have studied in mathematics, a straight line graph helps in solving a linear equation having two variables. To describe the motion of an object, we can use line graph. In this case, line graph shows dependence of one physical quantity, such as distance or velocity, on other quantity, such as time, which is the independent quantity. Now, what do you mean by dependent and what do you mean by independent quantity? The dependent quantity means we know that time is independent quantity, means the time doesn't change with distance, but distance changes with time. So, with the change in time, distance is increasing or decreasing, and so distance is called the dependent quantity, velocity dependent quantity on time. Time does not have to depend on distance or other physical quantities to increase or decrease. So, time is independent quantity. Now, distance time graph. We saw the relation between distance time as speed. Now, what does this help us in the graph? The change in position of an object with time can be represented as distance time graph adopting a convenient scale of choice. In this graph, time is taken along the x-axis. Always remember the independent quantity is taken on the x-axis and dependent quantity is taken on y-axis. In this case, time is independent quantity, so it is taken on x-axis, and distance is dependent quantity, so it is taken on y-axis. Distance time graph can be employed under various conditions where objects move with uniform speed, non-uniform speed, or remains at rest. So we will be seeing three forms of graph from distance time graph. Now, can you observe this graph? In this graph, the distance is taken on y-axis and time is taken on x-axis. The time is taken in minutes and distance is taken in kilometers. The points A, B, and the various other points on the line are showing the position of the object at that particular time. Now we know that when the object travels equal distance in equal interval of time, it moves with uniform speed. This shows that the distance traveled by the object is directly proportional to the time taken. Thus, for uniform speed, a graph of distance traveled against time is a straight line. So, whenever the object travels uniform distance, you will get a graph which is a straight line as shown in the figure 8.3. The portion OB of the graph shows that the distance is increasing at a uniform rate. Note that you can also use the term uniform velocity in place of uniform speed. If you take the magnitude of displacement equal to the distance traveled by the object along the y-axis. We can use the distance time graph to determine the speed of an object. To do so, consider a small part AB of the distance time graph. Draw a line parallel to the x-axis from point A and another line parallel to y-axis from point B. These two lines meet each other at point C to form a triangle ABC. Now, on the graph, AC denotes the time interval, that is T2 minus T1, while BC corresponds to the distance S2 minus S1. We can see from the graph that as the object moves from the point A to B, it covers a distance S2 minus S1 in time T2 minus T1. So the speed of the object therefore can be represented as v is equal to S2 minus S1, which is also said to be the y-intercept upon x-intercept. You can also write this as y-intercept upon x-intercept. We can also plot the distance time graph of accelerated motion. 8.2 shows that the distance traveled by a car in a time interval of 2 seconds. So here is the data for the distance time graph, which can be plotted on the graph paper, taking time on x-axis and distance on y-axis. And the various time seconds are plotted on the graph. You can observe in the figure that graph is not like the previous graph. It is a curve. It is not a straight line. Now what does this graph represent? The distance time graph of motion of a car is shown in the figure 8.4. Note that the shape of this graph is different from the earlier distance time graph. For uniform motion, the nature of this graph shows non-uniform linear variation of the distance traveled by the car with the time. Thus, the graph shown in figure 8.4 represents the non-uniform speed. Now we have one more kind of graph, that is velocity time graph. The variation in the velocity with time of an object moving in a straight line can be represented by the velocity time graph. In this graph, time is represented along the x-axis and velocity is represented along the y-axis. Can you tell me why? Yes, your answer is correct. Because velocity is the dependent quantity and time is independent quantity. If the object moves at uniform velocity, the height of its velocity time graph will not change with time. It will be a straight line parallel to the x-axis. As shown in figure 8.5, shows the velocity time graph of a car moving with uniform velocity of 40 kilometers per hour. We know that the product of velocity and time gives displacement of an object moving with uniform velocity. The area enclosed by the graph, velocity time graph and the time axis will be equal to the magnitude of displacement. So you can observe in this figure that the area ABDC shows the displacement of the object. To know the distance moved by the car between time t1 and t2, using figure 8.5, draw a perpendicular from the point corresponding to time t1 and t2 on the graph. The velocity of 40 km per hour is represented by the height AC or BD, and the time t2 minus t1 is represented by length AB. So the distance S moved by the car in time t2 minus t1 can be expressed as S is equal to AC into CD. That is the area of the rectangle, which is equal to 40 kilometers per hour into t2 minus t1 hours. That is 40 into t2 minus t1, which is equal to area of the rectangle ABCD, the shaded portion. So is that clear? That the distance traveled is time taken upon distance. That is, distance upon time taken will show us the displacement of the object. AC shows the distance moved by the object and CD shows the time taken to cover that distance, which is giving us distance or displacement. We can also study about uniformly accelerated motion by plotting its velocity time graph. Consider a car being driven along a straight road for testing its engine. Suppose a person sitting next to the driver records its velocity after every 5 seconds by noting the reading of the speedometer of the car. The velocity of the car in kilometer per hour as well as in meter per second at different instants of time is shown below. Now you can observe the data in the table 8.3. Now in this case, the velocity time graph for the motion of the car is shown in the figure. The nature of the graph shows that the velocity changes by equal amount in equal interval of time. Thus, all uniformly accelerated motion, the velocity time graph is a straight line, as you can observe in the figure. You can also determine the distance moved by the car from the velocity time graph. The area under the velocity time graph gives the distance, that is magnitude of displacement moved by the car in the given interval of time. In the car would have been moving with uniform velocity, the distance traveled by it would be represented by the area of ABCD under the graph. Since the magnitude of velocity of the car is changing due to acceleration, the distance S traveled by car will be given by the area ABCDE under the velocity time graph. So S is equal to area of ABCDE is equal to area of triangle ABCD plus area of triangle ADE, which is equal to AB into BC, length into breadth, plus half base into height of the triangle. In the case of non-uniform acceleration, motion velocity time graph can have any shape. You can observe this in the figure. As shown in the figure, velocity time graph that represents the motion of the object would whose velocity is decreasing with time, while figure 8.7b shows the velocity time graph representing the non-uniform variation of velocity of object with time. Try to interpret this graph. So the time of arrival and departure of a train at three stations A, B, C and the distance of station B and C from station A are given in the figure. Plot and interpret the distance time graph of the train assuming that its motion between any two stations is uniform. What do you observe? You will observe that one train is moving faster and the other train the train which is waiting at the three stations, you will be able to plot it on the graph. Now, same way, there is Firoz and his sister Sanya go to school on their bicycle. Both of them start at the same time from their home but take different time to reach the school, although they follow the same route. So, can you compare who is moving faster? When you will draw the graph, you might get the answer to that question. So, did you understand what does the graphical representation of the data tells us? Now, the graph easily shows us. So, now if we take the three graphs, we know that this position will be showing the distance. Now we understand this position is showing distance, that is on the y axis, and the x axis is showing time. Distance on y axis and time on x axis. Distance on y axis and time on x axis. Distance on y axis and time on x axis. Now, if the body is moving with the uniform velocity, then it will show the slope upwards, moving upwards with a straight line. If the body is moving or is in the retarded motion, it will show a slope downwards. If the object is stationary, means it does not move at all, then it will be showing a line parallel to the x-axis. It will be showing a line parallel to x-axis. This shows a stationary object, means the time is changing but the position of the object is same. And if we see a curve upwards or downwards, this is a graph showing non-uniform motion. And if the graph shows downwards curve, it is retarded non-uniform motion. So this is how we can show and read the graph and understand what does the graph interpret about the motion. And similarly, if we have velocity time graph, a straight line shows uniform velocity or uniform acceleration, and a zigzag line shows non-uniform motion. It can be of any shape. So we can understand how the relation between distance and time and velocity and time can be shown by various graphs. We can also show the speed or compare the speed of two objects using the graph. Say there are two objects, object A and object B. They both are moving with a uniform velocity, but which object is moving faster? How will you note it down? Then the object which makes a greater angle with the x-axis, say theta 2, and the angle theta 1 formed by object B with the x-axis, then theta 2 is greater than theta 1, and therefore speed of A will be greater than speed of B. This is what the graphs are useful for. They help us to depict various objects. You can calculate the distance by calculating the area under the graph. Say for an example, I want to find the area of this object which is AB. And here you have 0, 1, 2, 3, 4, 5, 6. That is our time. And here 1, 2, 3, 4, 5, 6. This is representing distance or displacement, and this is representing time. Now the area under A and B is represented by, so I can say that area of this particular portion is representing the distance covered by the object. We can even calculate the speed of the object using the graph. So the area of this triangle and the red triangle is the area or the distance covered by the object. We can label it as AB, C, D, and E. So area of ABCDE is the distance covered by object. Did you understand how the graphs are useful to us? So thank you for now.